So I just found those questions on sequences and series, and it's pretty nice. As you can see, there's a very clear pattern that emerges. Every even number has a negative sign, and every odd number has a positive sign. So based on what you take n, it can either vary from positive or negative sign. So right off the bat, I can see that I can divide it into two cases. Case 1 is where I'll be focusing on n equals even, and case 2 where n equals odd. So let's just move on with the first case. Let n just be any even number. So 1 square minus 2 square plus 3 square minus 4 square plus 5 square minus 6 square. And it's gonna end up, since it's even, it'll have a negative sign, minus tn square. And this, as it is kind of complicated. So, like, for example, if I have 1 plus, I mean, 1 minus 3 plus 5 minus 7 plus 9 minus 11, I can write this as 1 plus 3 plus 5 plus 7 plus 9 plus 11 and subtract uh like 2 times 3 plus 2 times 7 plus 2 times 11. Yeah, so you can take a 2 common and you'll have 3 plus 7 plus 11. So something similar. 3, I mean, I forgot a 5 there. So yeah, something similar. You can do something similar even in this case. So I'll take all of the numbers to be as is. I'll take this as summation n square because there's a direct formula for this. So I can write this as 1 square plus 2 square plus 3 square plus 4 square up until tn square. And I'm gonna be subtracting 2 times of 2 square plus 4 square plus all of the even numbers, if you can see the pattern, plus 6 square plus 8 square up until tn square. So right now here we started off with n numbers. So we're basically just flipping the sign over here. So even this one's gonna be having n terms. But all of the even numbers that we just took out comprise only half of the total number of numbers. Like if I have 1 up till 10, even numbers are gonna be 5 and you're gonna have like 5 odd numbers. Similarly, if I have n numbers in total where n is even, half of them are gonna be odd, half of them are gonna be even. So here I have n by 2 terms. And the thing is, I can see that there's a 2 common in all of them, a 2 square common in all of them. So I can write this as summation of n square plus, minus 2 times 2 square, because I can see a 2 square common in all of them. And this is basically 1 square plus 2 square plus 3 square up until tn square. And remember, if you're taking a 2 square common, it's basically like dividing by 2 square, but where you divide and multiply on the numerator and where you multiply on the denominator and the numerator. So this is what you're going to be getting, and again, there are only n by 2 terms over here, keep that in mind. So you guys should be familiar with this formula, which is n into n plus 1 into 2n plus 1 divided by 6, and this I can write it as 2 power 3. And you can use the same formula for this part. Instead of substituting n, you just be substituting n by 2. So n by 2 into n by 2 plus 1 into n by 2 into 2 plus 1, entire thing divided by 6. And if you want to simplify this, you can take LCM over here. And these two just cancel out. And yeah, you can cancel these both, and this just becomes 2. And once it's cancelled, I can just erase them. And I can already see that there's n into n plus 1 by 6. This part is common in both of these. So I would take out a common factor, n into n plus 1 by 6 into 2n plus 1. And this one, the 2 here gets multiplied into this bracket, minus 2n minus 4. So these both cancel, and you're gonna get minus 3, which can cancel with the 6 over here. So n into n plus 1 by 2 times negative 1. And this negative 1, just write it in the beginning, looks a little neater. So yeah, this is the formula for only odd numbers. I mean even, where n is even. So now, just like that, we'll be going to find it out for the n is equal to odd case too. But that's a lot of work, and mathematics has a lot of tools to reduce the work. How would you go on about that? So if I write, so here let me just write the formula again. So here you're gonna have minus n into n plus 1 divided by 2. It's a pretty neat formula. If you want, we can verify this by just considering 4 numbers. The sum of 1 square minus 2 square plus 3 square minus 4 square, where there are 4 numbers in total. So this just gives you minus 10. And if I were to use that formula, you get minus 4 into 5 by 2, which also gives you minus 10. So you know that this works for n is equal to even. Now I want you guys to kind of notice this pattern out here. Not a pattern, but yeah, something that you should be recognizing. I'll just write more terms. So plus 5 square minus 6. So now we have to solve it for the odd cases. So 1 is odd, 3 is odd, 5 is odd, 7 is odd. So right now, if I were to take 6, the sum of numbers till 6 can directly be given by this formula. If I want to find the sum of numbers till the 7th term, I'd just be adding this number. So based on that, you can kind of solve it. Or if you, yeah, that's pretty easy. So basically, right now, we can just assume n to be odd. We're doing case 2 right now. So let n be odd. If this is odd, the number previous to it is an even number. So I can say that n minus 1 is always, let's just consider 7 to be n in this case for like easier visualization. So n minus 1 is always going to be even. And for even numbers, you know that there's a formula. So all I can do is I can break this problem into sum till 6 plus sum of the nth number. So that's what I'll be doing over here. So I'd be substituting n is equal to, like, let's just consider this to be x, because why have the same variable? X into x plus 1 by 2. So here your x is just going to be n minus 1, and you'll be adding an n square. That's all the difference there is. So substituting n minus 1 into that, we'll have minus of n minus 1 into n minus 1 plus 1, which is basically 0 by 2 plus n square. How easy is that? So this again, you can take an LCM over here, and opening the bracket gives you n square minus n. Oops. So you're gonna have n square minus n, and simplifying this, you basically have 2n square minus n square plus n by 2. This is basically n into n plus 1 by 2. If you notice it, the only difference is that there is no negative sign out here. So in a more generalized way, for n, I can write this as x into x plus 1 divided by 2, where x is odd. But having a formula for two different cases seems like a lot to remember. It's just inconvenient. In maths, we like to simplify something as much as we can. So that's exactly what I'll be doing. So there's a really neat trick, in mathematics where they use powers of minus 1 to handle such cases. So if you notice this, if I raise this to an odd power, power 1, it's just gonna be negative 1. There's no change. Power 2, all of a sudden it becomes positive. Power 3, it's gonna become negative. Power 4, positive. So anything raised to the power, minus 1 raised to the power odd is always gonna give you a negative 1. But in this case, we see that for the odd numbers, there's actually a positive sign. So I want to reverse it from how it actually behaves. So if I just multiply this by negative 1 on both sides, so now this negative 1 into negative 1 power odd is always going to give you positive 1, plus 1. This is exactly what we want. And this can be written as minus 1 into minus 1 power n is equal to positive 1 minus 1 power n plus 1, because addition of powers is going to give you positive 1 if n is odd. But let's just take if n is even. So that time you're gonna have, using the same equation, let n just be an even number, like 2. It's always gonna give you a positive 1. So anything minus 1 power even gonna give you positive 1. So if I just, this is not how we want it to work. For even case, we want it to be negative. So if I just multiply both sides by negative 1 power even, so it's positive 1 times negative 1 times, that equals negative 1. So I basically have negative 1 power, let's just call it n again, because the number that we substitute or the answer that we get is purely dependent on whether n is an even number or a odd number, is equal to minus 1. So right now we got something that solves your negative and positive problem. So what I can do is I can just take that and substitute it at the beginning of the equation. So right now I have negative 1 power, instead of having x, let's just return back to our n plus 1 times n into n plus plus 1 by 2. And that's your summation of the series. It's kind of beautiful.